I'm going to talk about tangents and secants. I'll assume that you know the basics of circles. If you don't, I would invite you to watch the necessary videos. Okay, let's continue. So, a tangent is a line that intersects a circle at one point. A secant is a line that intersects a circle at 2 points. So the number of points of intersection determines whether a line is a tangent or a secant. Let me draw a picture of a circle, and then I'll draw a picture of some tangents and secants. That blue line is a tangent because it intersects the circle at 1 point. That purple line is a secant because it intersects the circle at 2 points. Okay? So let me label each of those lines so that there's no misunderstanding. So the blue one is a tangent and the purple one is a secant. Now let's have you determine the type of some line. All right, is that green line a tangent or a secant? So take a minute to think about that. Pause the video if you need to. All right, so that green line is a secant. Let's do another example. That red line, is that red line a tangent or a secant? All right, so that red line is also a secant. And how about this orange line? Is that a tangent or a secant? Okay, that orange line is a tangent. So to repeat, a tangent is a line that intersects a circle at 1 point. A secant is a line that intersects a circle at 2 points. Now, I would like to discuss a property of tangent lines. Tangent lines are perpendicular to the radii that they intersect. Okay? Let me repeat that. Tangent lines are perpendicular to the radii that they intersect. In fact, let me go ahead and type it out. Tangents are perpendicular to the radii they intersect. This is one of those important results that a lot of people forget, but if you remember, it might help you get some extra SAT points. All right? So here's a picture of a circle. Here's a tangent. And let me draw a picture of the radius that it intersects. All right? So what this is saying is that radii and that tangent are perpendicular. This is a very important result. Okay? Now, I'm not going to prove that result, but I would invite you to try to prove it. Okay? You can prove it by using proof by contradiction. Assume that the tangent was not perpendicular to the radius that it intersects, and you'll see that that's not possible. Okay? Some helpful facts to help you with that. The purple line segment is the shortest line segments with one endpoint at the center of the circle and another endpoint on the blue line. All right. So all other line segments are going to be bigger length. Okay, and so that'll help you to establish this. That's a hint. Okay. Now we're going to use this to do some exercises. Okay, but first let's do a proof. Okay, give me a minute to make a picture. All right, so I've drawn a circle with the center at point O, and I've drawn two line segments with a common endpoint and endpoints that are on the circle. Okay, so prove, if you can, prove if AX and BX are tangent to the circle, then AX is congruent to BX. Okay? So you might want to pause the video and see if you can prove that now. Okay, so I'll go ahead and prove it as well. So we can draw radii to the point of tangency, and we know that those radii are congruent. We also know that those radii are perpendicular to the tangent segments. All right, and let's also draw line segment OX. And what do we notice? We have two right triangles that share a common hypotenuse. So we can establish that those two right triangles are congruent from the HL theorem. And then we can use the fact that congruent parts of congruent triangles are congruent to establish that line segments AX and BX are congruent. All right, that's a very nice result. Okay, let's now do another exercise. So let me draw a picture. Okay, so I've drawn a picture of a circle, and I've drawn a line segment AB, which is tangent to the circle. Okay, so AB is tangent to the circle. That's a given. Also, AB is equal to 8 centimeters. And OB, the length, is equal to 12 centimeters. All right, what is the radius of the circle? Okay, pause the video and try to determine that now, please. All right, I'll go ahead and calculate it. So I'll draw the radius with respect to the point of tangency, and we know that the radius is perpendicular to AB. We know that line segment AB, we know that the length of line segment AB is 8 centimeters. The length of line segment OB is 12 centimeters. We're looking for the radius of the circle. We'll call it R. All right, because we have a right triangle, we can use the Pythagorean theorem. So 8 squared plus R squared equals 12 squared. R squared equals 12 squared minus 8 squared, or 144 minus 64, which is equal to 80. So R is the square root of 80. Let's see, 80 is 4 times 10. No, 4 times 20, 8 times 10, 16 times 5. So 4 root 5 centimeters. Okay? Let's do another exercise. So give me a minute to make a picture. Okay, I've drawn a picture of a circle with its center at point J, and I've also drawn line segments JM and KM. So KM is tangent to the circle. And the measure of angle J is equal to 63 degrees. All right. What is the measure of angle M? Pause the video and see if you can determine that, please. Okay, so I'll go ahead and do it. So we know that the radius to the point of tangency, JK, is perpendicular to line segment KM. So we have a right triangle, and we know that the angles of every triangle add up to, the measure of the angles add up to 180 degrees. So that means that 63 degrees plus the measure of angle M has to equal 90 degrees. And then the other 90 degrees comes from the right angle. So the measure of angle M is equal to 90 degrees minus 63 degrees, which gives 27 degrees. Okay? Now, how about this exercise? Again, give me a little bit of time to make a picture. So I've drawn a picture of a circle that is inscribed inside a triangle. That means that it touches the triangle at 3 points. I've identified those 3 points with black dots. Okay, so the points of intersection of the circle and the triangle divide the sides of the triangle into 2 line segments. Let me show you the lengths of some of those line segments. 2, 4, and 3. I'd like to know what is the length of the bottom side of the triangle. Okay, we'll call that x. So can you find x if that circle is inscribed inside the triangle? So pause the video and try to work that out now, if you like. Okay, so I'll go ahead and work it out as well. So we've just established that if you have 2 line segments that are tangent to a circle and they have the endpoints are the points of tangency and they share a common endpoint, then those line segments are congruent. So that means that this side has a length 2 and this side has a length 3. Therefore, x is equal to 5. Okay? Now, let's do one more. As before, give me a minute to make a picture. All right, so I've drawn a circle inscribed in a triangle. In other words, the circle intersects the triangle with respect to 3 points only. Okay, and suppose that I gave you the lengths of some of those line segments. Okay, so can you determine the perimeter of that triangle? Okay, pause the video and try to calculate that now, please. All right, so I'll go ahead and do it as well. So because we have pairs of line segments that are tangent to the circle, tangent at their endpoints, and they also share a common endpoint, we know that those line segments are congruent. All right, we established that fact. So therefore, we know that this line segment has a length 4, this one has a length 5, this one has a length 3. So we can sum up all those pieces, the lengths of all those pieces, and that'll give us the perimeter. Okay? One of the sides of the triangle has a length 5 plus 4. Another side has a length 4 plus 3. And another side has a length 5 plus 3. So let's add 9 to 7 to 8. Okay, 9 plus 7 plus 8 is 16 plus 8. That gives 24.